In the last lesson we talked about relative motion concept, and from that you can remember this expression that velocity of A with respect to B is VA minus VB. Now, to be more accurate, we assume that the ground is at rest, so this is velocity of A with respect to the ground and velocity of B with respect to ground. Same way, acceleration of A with respect to B will be acceleration of A minus acceleration of B. Now, these are all vector quantities, but in one dimension, one side is positive, one side is negative, right? So we can get rid of the vector sign and we can write them like this, right? Now again, this A is with respect to ground, this B is with respect to ground. Now let's have a look on this equation from a different point of view. So velocity of A with respect to B, or this is B, velocity of A with respect to B, so B is the observer, or B in B frame of reference, this formula are written. Okay, now let us say this is A moving with VA, and let us say B is moving with VB, right, with respect to ground, of course. Now if B is the observer, then he finds out that velocity of A with respect to him is VA minus VB. Now have a look in this way, that when B looks at A, its velocity is VA minus VB. Now what we do generally, if B is the frame of reference or if B is the observer, we assume that B is at rest. Okay, that is the trick. So if B is the observer, we'll assume B is at rest, and B velocity will be given to A in opposite direction, VB. Now if you see in B frame of reference, A has got velocity VA minus VB. Now you have two vectors, an angle between them is 180 degree, and the resultant is VA minus VB, right? So this is the trick. Okay, again try to understand. If B is the observer, you can assume that B is at rest and its velocity is given to A in opposite direction, so that the resultant velocity is this. Okay, this is the trick to solve questions. And actually if A and B are there, this is hard to imagine, but since there is nothing against them, we have to assume that there is no tree, no block which will make a distinction. Okay, so there is no way to say that whether A means some tree has passed or something. So B, when he will look at A, he will conclude that velocity of A with respect to B is VA minus VB. Okay, so this is the trick which we are going to use to solve one question, some questions. So we can do some calculation from one frame of reference by taking this trick. Okay, so from here, if B is at rest, B will take a measurement and he will conclude this. Now suppose we are doing this question, that there is something A and there is something B. B is running with 1 meter per second and A is moving with acceleration 4 meter per second square, and this distance is 10 meter. Right. Now the question is, find the time in which A overtakes B. Okay, find time in which A overtakes B. Now uh, again we are going to solve it using this relative motion concept. Okay, now in simple way, so in frame A, so if I assume that I am doing all the calculation in frame A, so what I will do, A will be at rest, right? So initial velocity of B with respect to A, okay, now observer is A, will be UB minus UA. Initial velocity of A is 0, UB is this, so this is this. Now what will be acceleration of B with respect to A? So acceleration of B with respect to A will be AB minus acceleration of B is 0 and this is 4, so minus 4 meter per second square. In the simple way, and of course whenever we do any problem in kinematics we have to select origin, so we are assuming this is the origin, 0 is my origin, this direction is positive and this direction will be negative. Now so in A frame of reference, what he will find that this B, okay, B, A is at rest, okay, A will be at rest, B is moving in this direction with 1 meter per second, and as I told you, in A frame of reference, A will be at rest, A acceleration was in this direction, so in A frame of reference you will give its acceleration to this in opposite direction, and it is going in this direction with, it has acceleration in this direction which is 4 meter per second square, of course, which is negative, right? So when A will look at B, when A will look at B, this is the scenario. Now when A will overtake B, then what will be the distance between them? So in A frame of reference, this is at rest, right? This is somehow moving in this direction with some acceleration and with some velocity. Now if you guys remember this formula, S equal to S naught plus ut plus half at square, right? Now this is the correct formula. Okay, you have to know that this S naught is there. S naught is the location of the body initially. Now in frame of A, if I apply this formula, okay, see this will write in the frame of A. Now in frame of A, what is the initial location of B? It is from here to here, it's 10, right? And when B will reach A, what will be the S value? It will be 0. Okay, so A is at rest and somehow B will start moving in this direction, right, in his frame, and they might cross. So if you go by this, I am applying in this frame, then this S finally will become 0. S naught initially was 10, right, and this is initial velocity of B with respect to A, 1 meter per second, so plus 1 t plus this acceleration is this, so this will be minus 4 by 2 t square. So this here you are going to get 0 equal to 10 plus t minus 2t square, or 2t square minus t, take everything to this side, minus 10 will be equal to 0. Now you can solve this quadratic equation and you will get t to be Okay, if you use quadratic equation concept, you will get t to be 2.5 second, or you will get minus 2 second. Of course, this is the answer. Now again I want to reiterate that in frame of A will be at rest, B will be in motion. Now B initial velocity is in this direction, you can see, but it has huge acceleration in this direction. So you can assume after some time this will cross this. So when it will cross, then this one will be 0, this one will be 10, and you will get, so in this time it will cross it. Now suppose you are not happy with this, you want to do in ground frame, okay, or this you don't follow, so in ground frame also you can do. So suppose in ground frame, okay, so means your old knowledge, ground frame. Now let us say that this is my origin, let us say they overtake somewhere here. So A is here and B is also here. So overtake, they take in time t, they overtake, right? So what will happen, if you see, this will be the distance moved by B, let us say S B, and this will be the distance moved by S A, right, to overtake it. Now using this relation, you can see that this SA, okay, this SA will be equal to, this is 10 plus SB, right? Now this will be nothing but initial location is this, and this is 0, so this will be half AT square, this is 10 from here to here. Now we are assuming that this has started from here, so this will be, its acceleration is 0, and this is going to be 10 plus, this will be nothing but this t, okay, 1 into t. So if you sort it out again, this is 4, so this will be 2t square 10 plus t, so 2t square minus t minus 10, 0. So again you will get the same answer. Now we are going to do one more thing using this relative motion concept. Now suppose again we are going we'll use the same thing. Suppose 40-meter building is there and one ball is thrown with 20 meter per second downward and at the same time 20 meter per second upward, and let us name them as A and B. The question is at what time they will collide and where they will collide. Okay, so what time they collide and where. Now again let me try to do with the idea of relative motion, and let us say this is origin, this is my origin, this is my y-axis, okay, this is my y-axis, positive, and downward will be negative. Now in A frame, now A is at rest. So in A frame, initial velocity of B with respect to A will be UB minus UA. Now we have assumed this direction to be positive, UB is downward, which will be negative minus 20, and this is, so this is minus 40 meter per second. Right. Now, what is acceleration of A? B with respect to A. So, acceleration of B minus acceleration of A. Now, you know that as anything goes up or down, acceleration will be G only. So, acceleration is going to be minus G because it's downward for both. So, this is going to be minus G. This is also minus G. So, minus G. So, you will see acceleration will be 0. Now, it turns out that in frame of A, B is moving down with 40 meter per second speed and its acceleration is 0 in frame of A. Okay. Now, when it will collide in frame of A, when this distance will reduce to 0, right? Now, then only it will collide. So, let us say the distance between in frame A, this distance becomes 0 at time t. So, if I go by that formula, S equal to S naught plus ut plus half at square. This is in frame of A. Final S has to be 0. This ball will come here in this frame to collide. S naught is the initial location of this, which is 40. This is origin, so this is 40 plus this is minus, so minus 40t, and A is 0. So this will give you t equal to 1 second. So in 1 second they will collide. Okay, in 1 second they are going to collide, and where they are going to collide, so again you can use this, since we know what is the, so in frame A, let us say they collide. Okay, where they are going to collide, so to do that we can just use this equation, S equal to again S naught plus ut plus half at square. Let us say we are doing it for this, fine, in ground frame now we are doing. So let us say this ball reaches here at some time. So this is S, U is 20, T is 1, and A will be 9.8. Let us say it is given by 2, T is 1. So S will be 20 minus this will be 4.9, 15.1 meters. Now, where they will collide, I have used, because time is known, I have used S equal to this in ground frame for this, right? Now, you can all try to do this in ground frame and you will get the same answer. Okay, this is just a way to do it. Now, we are going to do question not related with number. This will be like, suppose somewhere A is here and somewhere B is here, and at time t equal to, this is suppose origin, and at time t equal to 0 they are here. So this distance is, let us say, xa0 and this is xb0 at time t equal to 0. Now let us say that they start moving with velocity va and this one moves with velocity vb. Now, so at time t equal to 0 they were at rest and then they start. Okay, at t equal to 0 they were here and they start with this speed. So after some time, we all know that, let us say A reaches here, so this will be xa at time t, and let us say this B will be here, let us say xb at time t, there here from origin. So this is at time t. Now we all know that what will be value of xat. So xat will be xa naught plus vat. So xat will be xa naught plus vat, and xbt will be same way xb0 plus bbt. Now if I subtract this, I am going to get xbt minus xat equal to xb0 minus xa0 plus vb minus vbt. Right. Now if you see this expression, then this term we generally called velocity of b with respect to a, right? This term. So this term counts automatically. Now what we are going to do, we are going to do some graph related with xt. So first case we are taking, suppose va and vb are same. Okay, so va is equal to vb, so they both start with the same speed. How their x and t will look? So if va is equal to vb, this is xt graph, b starts somewhere far away from the origin, this is origin, so b will be like this and a will be like this. This is xa0, this is xb0. You can see if VAB is equal to this, then this term will not, and this will be constant. They are parallel. Okay, so this is the case. Both lines will be parallel, and as you know that its slope gives you velocity or speed. Since speeds are same, they will be parallel. Right? They will never meet each other in this case. Now, what if suppose VA, okay, let us say VB is greater than VA. Second case. So what will happen here? So this is X, this is T. You can see if VB is greater than VA, that means, let us say I am doing like this, and now this is B, this is A. VB is greater than VA, that's why the slope of B is more than A. They are not going to meet any time, and the graph will look like this. Okay, now we can also take VA to be greater than VB. So in this case, what is going to happen? So this is now A, this is B. You can see slope of A is more than B, and they will meet at some time t. Okay, so this is X. Now what if, let us say VA is negative of VB, or let us say VB is negative of VA. What is going to happen here in the graph? So if velocity of B is negative of A, means slope of V, this one will go something like this, this is B, and A, both slopes are same, one is positive and B will have negative slope and A will have positive slope, and again they are going to meet at some point T. Okay, now this is the basic idea of relative motion in one dimension. You can find a lot of things, but what is more important, you can do now questions in two way. One you can do in ground frame, one you can do in relative frame. Whenever you work with relative frame, you have to find the frame in which the body, you are observing the body, and that body will be at rest. Then you have to give its velocity or acceleration to the different one in opposite direction. Then you can use the kinematics, and these are all very simple concepts. I guess here only one idea you need, that the slope is, okay, slope is nothing but this angle, right? So here these two angles will be same because they are equal. Here this angle will be more than this angle because VB is more than VA. Here VA is greater than VB, so this angle will be more than this angle, and here whatever angle this will make in this direction, this will make in this direction. They are just equal and opposite. So generally anti-clockwise direction is taken to be positive, right? So this angle will be negative, so that's why it is called negative slope. Fine. Okay, I will see you in the next video, and I will discuss about two-dimensional relative motion in that. Okay, thank you.